Okay, so when we talk about autoimmune disorder, so we do know that maturation of T cells take place in the thymus. So millions of the T cells are destroyed because they have the T cells receptor, TCR, that complementarily bind to the self-antigens. We have to destroy them. Are you clear? We cannot let them go out. Okay, but sometimes these T cells, we don't know how, don't know why, can evade from destructions. And what happened here, they actually stimulate the immune response against the body self-antigen. So the start always take place involving antibody and cytotoxic T cells. So once, because when helper T cells, particularly helper T cells, when helper T cell release cytokine, there's no way to stop, guys. It's like you ignite the bomb, okay? You have no way to stop it already. Are you clear? You can see the reaction continue, okay? As long as cytokine. So it means that always involve the cytotoxic T cells and also the antibody, okay? So in some autoimmune disease, the attack will be localized, so mean a particular organs only, or it might be systemic, so mean against the whole body. Okay. So example autoimmune disorder that's generally common is a myasthenia gravis, attack at the neuromuscular junction. You learned about neuromuscular junction before, right? Yes or no? The muscle. Now, you want to contract the muscle, you need the neurons, right? So you have the motor neurons. You learn about this, sensory neurons, intermediate neurons, and motor neurons. So these motor neurons will give the action potential, or usually you call it impulse, right, to the muscle, so the muscle can contract. So this disease actually, we have the immune cells, or what we call these white blood cells, right, particularly helper T cells, okay, targets or antibody targets our neuromuscular junction. Okay, neuromuscular junction basically means it's the junctions, the cell junction between the neurons and the muscle cell. Are you clear? So this is the muscle cell. This is the, you have the neuron. So neurons are firing this impulse to ask your muscle to contract. Are you clear? So in this process, you can see that it targets your neuromuscular junction. You learn about synapse, right? So it's something similar to the synapse. Synapse is between two neurons, sensory neurons and the motor neuron. Okay, neuromuscular junctions, neurons and your muscle. Okay. Multiple sclerosis. Multiple sclerosis basically affects, okay, will cause a paralysis, affect your central nervous system, your spinal cord. Okay, we're going to learn this one in A2. Rheumatoid arthritis, your joint. Okay? Rheumatoid arthritis, joint. Type 1 diabetes basically means that the immune cell attack our beta cells in our islets of Langerhans. Because we do know the islet of Langerhans, we have two kinds of cells, alpha and beta. Alpha release glucagon, beta release insulin. Still remember? Why is so blurry, guys? Look at me. This, you should know about this, okay? Islet of Langerhans, so you have alpha and beta cells. So alpha cell release glucagons, beta cell release insulin. So these beta cells are targeted by your own immune system. Destroy the beta cells, so it means that the body won't produce sufficient insulin. So diabetic mellitus type 1, okay? And lastly, it's a systemic, lupus erythematosus, SLE. SLE actually quite, I don't say common, but generally, if you look at the individual with the SLE, 90% are female, 10% are male. Normally develop at 30 or 40 years old, where the girls reach these 30 or 40 years old. All of a sudden, now we do not know what is the main cause of this SLE, but it's a systemic. So when it's systemic, it's very, very dangerous, because this antibody can go all over your body and it can simply target any organ. Okay, so in male, they normally target kidney and also the heart, which are very, very vital organs. You try to imagine without the kidney, or kidney failure, or heart failure. Okay. So autoimmune disorder, in this case, myasthenia gravis targets neuromuscular junction. Multiple sclerosis target the central nervous system. So once the target central nervous system, then it could cause a paralysis. Now, one of these, or why multiple sclerosis, or your neuron actually do have this what we call the Schwann cells, the myelinated neuron. Have you learned about this in your SPM IGCSE, myelinated neurons? The neuron actually have the node of Ranvier. Why some yes, why some no? Or SPM syllabus got different one, is it? North Malaysia learn different set of syllabus, and South Malaysia, Central Malaysia, Klang Valley, we have different. Okay, so this node of Ranvier basically allowed the rapid transmission of the action potential. Are you clear? But because of the antibody or the cell destroy this neuron, so means that the transmission of action potential or impulse go very slow until you won't be able to control. Okay, so you have the body paralysis. Okay, progressively, rheumatoid arthritis will have effect of a joint. It will cause the destructions of the joint, so you can't bend your finger. Okay, your finger will deform. Okay. Type 1 diabetes, I say that due to the islets of Langerhans, right down, particularly beta cells. Okay, so therefore they disrupt the cells that secrete insulin. Systemic lupus erythematosus, you can see the skin, kidney, and joint normally, or the heart. So progressive deformity take place in the particular tissues or organs. Okay. So since myasthenia gravis have been in our syllabus previously, so let us look at this myasthenia gravis now. So it's autoimmune disorder targets the self-antigens at this neuromuscular junction. Now, neuromuscular junctions, you have learned about the synapse, right? How the impulse actually travel from one neuron to another neuron. Still remember the synapse involved the neurotransmitter. Have you learned about this? Okay, so now, quick one in this diagram. So you're going to learn this one again in detail when we come to the A2 topics, but generally, when we have the action potential, okay, it's a communication between the motor neuron and also our muscle cells. So basically, neurons come here and tell it, now contract. So the communication is cannot be the voice message lah. Are you clear? Okay, the neuron will say, hey, hi, please contract. Cannot. Okay, so the signaling pathway here involves the molecule called neurotransmitter. It's something like hormone, right? Chemical signaling molecule. Okay, so it means that now neurotransmitter is released. Can you see that this is a vesicle released by exocytosis? Okay, so it's something like our signaling pathway. You must have the receptor. Can you see that? You must have the receptor. Can you see that? So this receptor, okay, are going to bind to the neurotransmitter. The binding of the neurotransmitter to the receptor will cause a series of reactions and result our muscle contraction. So basically, it's a form of communication. Are you clear? Okay, so let's look at this in general. So when the motor neuron terminates, they release one of these neurotransmitter known as acetylcholine. I'm not sure which one you learned before, neurotransmitter in general. Okay, so acetylcholine is more specific. So it binds to the receptor. So this one you do not need to know at this moment. Stimulate the channel to open. It's a series of the actions. So it will cause the muscle contractions later. Are you clear? So it must bind to the receptor, yeah, right? Receptor. So it's a cell signaling. So it's because this topic quite related to few topics in our AS. Even though means I have been removed, I still feel insecure that I didn't tell you guys about this. Are you clear? Okay, so you can see that this receptor protein is very important to receive this neurotransmitter and cause the muscle contraction to take place. But the people with myasthenia gravis, they have the helper T cell that's specific for this cell surface receptor for acetylcholine. So once they bind to your receptor, they're going to release cytokine. So the release of cytokines will cause the cytotoxic T cell to be activated and also the B cells to be activated. So when B cell become activated, they're going to proliferate to become the plasma cell and secretes antibody. Try to imagine now the antibody, okay, bind and block the receptor. When they bind and block to this receptor, can this receptor receive signal? Can it bind to acetylcholine? Cannot. So what will happen? Muscle can't contract properly. Means that the signal is not strong enough to allow us to contract our muscle. And luckily, this is localized. So it means that it happens as particular region of your muscle. It's not whole body. Are you clear? Myasthenia gravis, it may progressively spread to other parts of our body, but generally, at first, it starts at the particular region. Are you clear? Okay, so what actually happened here is muscle fiber now absorb this receptor antibody complex. So it means that this is the receptor bind with the antibody. This receptor no longer can function already because it binds permanently. So muscle cells actually destroy this receptor. useless. So it means that the number of receptor become less and less. So when the receptor become less and less, so the signaling molecule less bind, so muscle become weaker because it can't contract anymore. You don't receive sufficient information. So I speak very, very soft. You can't hear it because signaling molecule is not enough. Are you clear? Okay, the idea. So therefore, without acetylcholine receptor, muscle cells do not receive any stimulation, and muscle cells are not stimulated, muscle tissue start to break down. Okay, this is a very, very common. Muscle cell is one of the what we call the tissues or the cells. If you don't use it, it break down the protein. So muscle proteins break down, so it means the muscle totally gone. Are you clear? Become not non-functional. So you can see that in this diagram. Under normal conditions, you can see that we're firing. So keep on have this the signaling pathway, a lot of muscle contractions, but now you can see that the number of the receptor less and less. They won't be able to fire any action potential. Can you see that? We have one action potential here. Can you see that? So one contractions, this one no contractions. Okay. So the typical symptom of myasthenia gravis is a muscle weakness. Not definitely become weakness because you can't actually contract, and get worse with activity and involve the rest. So affected muscle, why I use the word affected muscle, it won't be whole body normally. Are you clear? It won't be whole body. Okay. So if fatigue very easily, drooping eyelid is the most common early symptom of a myasthenia gravis. When you open your eye, okay, the eyelid, actually you're contracted. Try to imagine, you contract the eyelid. Are you clear? So if an attack takes place at your eyelids there, you will have this what we call the drooping eyelid. Okay, I know that some of you, even though you don't have the myasthenia gravis, but your eyelid always like this, okay, in the class, but at night, they're always no problem. Okay, but early morning, drooping eyelid in the class. Okay, so myasthenia gravis. Okay, so you can see that in this form, because contractions of the muscle is not strong enough to hold it. For us, strong to hold it, right? Can you see that? Okay, but you can see that in this case, your muscle contraction not strong enough to hold it. Okay. Now, how about treatment? We have no cure in this case. When as long as autoimmune disorder is developed, we have no cure at all because memory Bs are always there. Are you clear? It's always activated. Okay, autoimmune disorder. So, but we can use a drug to trick it. For example, we use the drug to inhibit the enzyme in the synapse that break down the acetylcholine. Now, what does this mean? We have the acetylcholine to bind here. Muscle contraction take place. When finish muscle contraction, the signaling molecule, we have to remove them. If no, your muscle continue to contract. Are you clear? So you have the enzyme known as the acetylcholine esterase enzyme to break down this, okay, acetylcholine or neurotransmitter. So what we need to do here is to increase the effectiveness of the muscle contraction. We block this enzyme so that this signal will remain high concentration at the synapse. So give us sufficient, okay, the signaling molecule to have the contractions. Are you clear? But it's just a form of treatment. You won't be able to cure it, okay? So the effect is the drug is to increase the concentration of acetylcholine in the synapse. So therefore, stimulating muscle fiber to contract lasts for a little bit longer compared to without the treatment. Okay, so with this, I have done for this autoimmune disorder. Okay, so once again, autoimmune disorder have been removed. This part, the topic have been removed totally from the syllabus in 2022. Okay,